Okay, so what's up, my dear people? Today we're here for the first video of the Aegis project, or at least maybe Aegis Reborn project. So for context, I'm someone who's studying in computer science and mathematics. I have a deep interest in those two fields, and as someone with interest in that, you'd expect that I also have interest in AI and making money, which, well, you'd be right. So let's go in the code. And like right now it's a mess. Frankly, it's a mess. I used RoboDev to build the foundations, and I essentially stopped using it currently because it just kind of sucked. It built something, but every once in a while, like what it gave wouldn't really make sense, and I'd be like, what is happening? And when I finally looked at the code and like stopped the vibe part of vibe coding, I realized that many of the methods that it had implemented were basically just stubs of methods, so nothing actually implemented, and that a lot of things that it did implement were just gibberish. The big issue now is that I have a 300 or so thousand token code base, and I don't know it deeply enough for me to be able to just modify it as I wished I could. Which means that now I basically now I need to read that, okay? So let's do ls to see. So we got best strategies, which is just like an output of a generation I did. Bit data is Bitcoin data. My cargo log files, because this is a Rust project. Config JSON is the place where you do the configuration. And enhanced trading grammar, and this could low-key be cut. And this might not make sense for those that don't understand that kind of stuff. Okay, essentially the idea here is that this is a grammatical evolution project. So I was like, well, can I use it for trading? And so that's how I started. The idea of generating a grammar is that it allows you to define the atoms of whatever solution that you're trying to generate, and then let a computer program use those atoms and generate something that actually makes sense out of it. And since everything is supposed to be automatically driven, you will probably end up with solutions that are good, maybe even better than what a human could come up with. So first we'll go to source and main, because that's where the code starts. I looked a little bit at it. This was supposed to be a vibe coded project from beginning to end, and I wanted to see where I could go with minimum input to see where AI is currently. And I kind of gave up along the way because it just became really, really, really tedious to have to just clean up context and whatever. Yeah. So let's see. So we start with the imports. So we see that we have create backtesting candle. This is the module, the backtesting module that does the evaluations, and the candle is like a struct that stores the CSV data that is passed to the program. Aegis Reborn, we just import everything. Nice clap. This is CLI program. And yeah, I guess it doesn't hurt to just run evolve quickly to show what this is out. So outlog, and I think I need a ampersand here. So boom. Okay. So let's sp out. Boom. Okay. So let's skip to the end. This is the kind of output it gives. So just at a glance, I know I already caught a few, let's say, it's not quite a bug, but annoying things. Like here, for example, it's gonna have multiple generations, but tell me, and generation 0, so there's something wrong with the loop. Like you see, it tells me 50 out of 50, but yeah. So either there's something wrong with the loop, or there's something wrong with just my understanding currently. But we see that it's actually doing some evaluation. So whatever fitness function has been implemented is doing something. We'll need to go look at that after. We see that at the last generation, the best fitness function is this here. And the average is quite piss poor, but it doesn't matter. The top solutions, we see that many solutions are exactly the same fitness. So that tells me, yeah, many of the solutions are exactly the same fitness, which is quite unlikely, which tells me that they would all probably be the same solution, if I'm honest. Well, except the 0 ones, which could happen if they are just bad solutions. But everything that has more than 0, the fact that they're all exactly the same tells me that probably we have some hard coding issue here. Okay, so yeah, that's fun already. Let's look at that. Yeah, and so at the end we have our best solution, which did 114 trades, and let's look at the solution that it generated. So by default, let me look where we say, so let's open that up here. So best strategies. So that is the format. Okay, it outputs a JSON file, and it gives me a strategy in like, well, as an object, like an object, and we get abstract syntax trees out of it. So the best strategy tells us that if 30 is less than 30, how is that the best? Oh my gosh, okay. So if 30 is less than 30, buy, else buy. So just buy regardless all the time. That's because this will always be false. Like 30 is not less than 30, but you just buy anyways. Okay, so that's funny. For the exit, what do we do? If the close price is less than is greater than the Bollinger middle period, so essentially if the close price is above the 20 SMA, a single moving average, then we sell market, else we just hold. Okay, that this is semantically, it makes sense. Okay, right? Okay, interesting. Then for take profit, we just hold. That's the only action. And stop loss, we just hold, so we don't have any security. And we won 63 trades, lost 51. Max drawdown of 11%, sharp ratio of 5. That's crazy good. That's suspiciously good. And a win rate of 55%. Okay, interesting. That is weird. So I guess that since the rest is updated, it might be that the code just doesn't update these for whatever reason. And risk-adjusted returns, yeah, it might be that the code just doesn't adjust these for whatever reason. But yeah, essentially that's the kind of outputs that we get. So let's close this. Let's see what the AI gave us. So it imported Tokyo, that's nice. So Tokyo is an async runtime for Rust. And so yeah, as you see here, it's an async function. If you don't have Tokyo main like that, you won't be able to put async in front of fn main. We start with logging, that's nice. We have level filter info, so we filter everything info and above, and we are gonna see that the code is littered with info. Like a lot of the printing to the console is done with info, which is nice. So starting Aegis Reborn cryptocurrency trading framework. Yes, I'm using cryptocurrencies. Not because they're sound investments, and I'm frankly, if I'm thinking about using like just renowned cryptocurrencies, like just trading Bitcoin, for example. I wouldn't trade Fartcoin or whatever. But yeah, that's the idea, because they have more volatility, and so since they have more volatility, there's more opportunities to make money. And if the framework is able to capitalize on it, that'd be quite nice. So what do? We start with, yeah, then tell them what it was, huh? So Aegis Reborn, version this, author that, and then we have the first command, evolve. This is what we ran earlier. So it just runs the evolution to generate a new set of solutions. We can pass a config with, well, these commands. We can pass market data. By default, we give the bit data.csv. We can pass the generations. By default, it's 50. Population, by default, it's 100. And then the output file, by default, it's best strategies. Then we have the backtesting module, which frankly is kind of overkill for me at this point, since I'd want to like if I have a leaner framework, everything else can be added on top afterwards. So frankly, maybe it doesn't even make sense out the backtesting function. I think leaner is better at this point, and then features can be added. So I'll start by decapitating this to start with. I'm not gonna bother with this here. Okay, so boom, match. Yeah, I'm gonna keep the, how's it called, the match thing there, so that in the future, if I want to extend it, I don't need to add a new thing. But yeah, I'm gonna remove everything else for now because just leaner is better at this point. Okay, so we support only one command at this point. Okay, let me see. Am I able to do cargo run help? Normally I should still be able to do it. Oh, what is it? Oh, wait. Cargo run help, what did it tell me? Yes, okay, I'm still able to do it. That's perfect. So, then run evolution is a command that is called when we call the cargo run evolve, when we call the program with evolve. Okay? And so what do? We take the matches, config, generations, population size, data path, etc. Then we loaded the config from the util using the config loader from the utils. And then we override the config with the command line arguments, which in this case here means that since we have a default for the generations and the population size, this overrides always what is given in the config, which might be stupid. Yeah, it's kind of stupid, because if I have a config and I run cargo run evolve, by default I'm expecting it to just run what I put in the config. So here the solution is actually quite simple. Well, at least the solution that I'm thinking of is quite simple, and since I think it'll work, we'll just do that. We'll just put a default value of -1 and -1 for both of them. Okay, which means that we're gonna read it from the default config. Okay, because we have a config JSON that is there by default in the program. And if nothing is passed, we're just gonna read directly from the config. Okay. This might cause issues later on, but hopefully not. So what we do now is here, we'll do if generations equal -1, we do config evolution generations. Frankly, I should just do less than 0. Because if the user puts some dumbass shit, some dumb thing, I don't want to like replace and then have an error later. So it just makes sense to, if generations is less than 0, is less than or equal to 0, because it doesn't really make sense to have 0 generations, then we want to just take what is already there. Else we want to assign to override. And we'll do the same thing here. If generations is less than or equal to 0, we'll take what we already had, config evolution, population size. Okay? And else we're gonna take the new stuff. Okay? So that gives us a basis so that if we run, let's say cargo run, let's do two things. The first thing is that we're gonna cat the config. So we see that here we have 5,000 generations, which is a ridiculous number. Let's see if what we just did changed things. So cargo run evolve. I'm expecting, since I'm not going to pass any parameters for that it's going to run 5,000 generations, which is going to take a while. Well, there was an error. What happened? Invalid digit. Kind invalid digit. Okay. Well, I guess we'll do cargo and evolve to out log, then vs. Yeah, that logged. So what is our issue here? Wait, that's it? Starting grammatical evolution and parsed error. Okay, wait, let's see. I think the issue is the negative ones that I put. They might not be, okay, I see. So, we'll put 0, I guess. And 0. If I do that, does it work now? Since I did the equal thing, it shouldn't really change anything. Okay, it's taking a long time, so it worked. Yes. So now I just cargo run evolve that and see if. Yes, it is running. It is running. Perfect. So you're good on that side, which is nice. So let's close this. And then, where were we? Control O. Yes. Okay. So now, use the grammar file specified in the config. So let grammar path config grammar file. Yes. And what do we do? So we load the grammar at the path, and then we create. Let grammar match a grammar parser parse file. So if there's been any error, we return here directly, and at this point it is going to be the end of the file. Of the thing else, we return the grammar that was parsed. Okay, and that grammar is going to be in grammar. So then info grammar loaded rules, and so let's do cargo run evolve again with a G of 1 to see this happening. Grammar loaded 13 rules, and so if we check that ourselves, 13, what am I trying to do? VS split grammars, and RPN grammar is the one that is there. We'll count. And yes, we do have 13, so that's perfect. So up to now, nothing weird. Then what do we do? Okay. So at this point, it's really just loading stuff. Okay. So we load the grammar, and the parser seems to be working fine. So we'll see that after. Then we create the backtest config. So we have the backtesting module. Starts us with a capital of 10,000 K. 10,000, not K here. A transaction cost of 0.001 of 001, slippage of 0005, start date here to 2 years in the past, and end date is just today. Okay. So yeah, the start date is 2 years in the past. It's a 2 years backtest. That's what I meant. Backtesting engine. We are gonna create a new backtest engine from this config. So. Up to now, nothing weird. We'll need to look at the actual implementation of that. But for now, nothing weird. Let evolution config, population size, config evolution. Yes, okay, we're just creating a huge. I don't think I need to go into those things in detail. Those values here were chosen by the AI itself. So we'll keep them as is for now and then change them if we see that we need to tweak. At this point, the goal is like really just is getting an MVP out, something that actually works. And actually, like from what we saw, there's something already working right now. But yeah, there's definitely quirks hiding here. So loading historical data from data path. Let candles utils candle loader load from file. Okay, so we load the candles, that's fine. we create an evolution engine, which is how we're going to do the evolution. And then the best strategies are just going to be the return of calling this function. Then when we're done, we save that, and then we're done. Okay, so that means that really the only components we care about at this point, let's look here, because that means that we can simplify this quite a bit. I don't care about running backtests in this app. We're gonna put it down later if we want. I don't care about running analysis here because I don't trust it anyways. Running validation, that actually might be useful. We might want to keep that one. Yeah, we might want to keep that one. But so we'll keep that one there because it sounds useful. And so we already simplified greatly actually this file here. And so, well, so now what do we want to do? We want to create a new command. So we will create a new command here. Okay, so let's go back here. What does it need to config? I think intuitively, I'd assume that validating configuration files and validating grammar would be two different things. No, like they're both important in the start, but they'd be two different functions. So yeah. It doesn't seem like it'd be a pain to refactor it either. So let's do that. Let's bring this here. Okay. Let's paste this here. And let's go to the editor function. And we'll do that pretty much. Okay. Then we'll do grammar validation completed successfully. We'll do okay up here, grammar path, starting grammar validation, run grammar validation, I guess. Okay, and so now we're gonna have a function that is actually atomic. So let's keep the doc files thing that the AI did, because that's a good thing. Validate configuration file, async, then run configuration validation. The matches is going to be the clapped cargo format. Boom. Okay, so now that's good. And now there's two things left to do. So the first thing is to go to, and we have as a command validate. Oh frick. I really need to put a relative line, so I just never bothered to do it. Validate grammar. And so now we no longer need this. Okay. And actually for this, I think it doesn't even make sense to have a default value, really. Because... no, it does make sense. It does make sense. So... yeah, it does. The next thing we'll do is come here and add the new matches. So the command is validate grammar. First one. It's kind of annoying me that I'm having grammar before run validation grammar. I think that's the name I give it. Matches await. And allows nothing. It's pretty much the same thing, just whoops. Getting it out. And then we're gonna have, just to be consistent with the way I wrote it above, I'm gonna have validate config here. But I don't like the fact that it's not in alphabetical order. So now let's make sure it's run configuration validation. Why did I put run here? Yeah, that's a stupid name. That's a stupid name. Run configuration validation. That's a silly name. I'm going with validate configuration. That's much better. And that's much easier to remember as well. So, B, validate configuration. Boom. So now, I don't think it's used in many places, so it shouldn't really matter too much. Then we'll do the same thing here. Whoops. Validate grammar. Boom. And so now we'll go to the run. There we go. And we'll do, oops. Oh. And I think I have it as valid. Yeah, just have it as valid configuration, right? Yeah. I'm mapped at validate config. Okay, so hopefully this is good enough. So let's cargo format again. And then let's cargo check. Okay. Due to 3 previous errors, okay. Okay. So it has something to do with the way I did the commands. Subcommand. So I did the subcommands wrong. Is that the issue?
It seems that, well, at least that's my guess. That's my guess. Maybe I'm still wrong about that. But I'm supposed to wrap one command, one subcommand thing at a time. So yeah, that's it. Great. So now let's see. Can I? Yay! Okay, it seems that we're good now. So outlog. Yes, no longer errors. That's fantastic. So now let's do cargo run validate config. And it tells me that the config is valid. So that's cool. What about cargo run validate grammar? The grammar files is not found. So, okay, so that's easily fixable. Yeah, no. Oh my gosh, I am non-tibak. Okay, great. Okay, so now we are actually able to grammars and then RPN grammar. Boom! It works. So we are good. We are even better than good. So now let's just git commit all of this. Git add all of this. And git commit. Started leaning down the code. So I think that's it for today. Thank you very much for watching. So if you enjoyed this, if you like me to cover different things next time, whatever, tell me in the comments, and yeah, thank you very much for watching.